Morning, we're back for day 8, and in a remarkable turn of events, Ictrabot and I are equal on points after yesterday's problem. Sample answer part 121. I think it's a 2D grid problem, and it looks like it's 100 by 100. Oh, that's not bad right. Number of trees that are visible from outside the grid when looking directly along a row or column. I've played a board game like this. It's called Photosynthesis or something. Photosynthese. The number in the map is the height of the tree. Each tree is a single digit. Tree is visible if all of the other trees between it and an edge are shorter. Up, down, left, right. Trees around the edge are visible. Is a 0 height tree still a tree? Yes. How many trees are visible from outside the grid? Okay, I will give it some silent contemplation. Well, we've got the top row plus the bottom row plus the two sides. And then I think we want to scan in from every direction until we reach a 9. Is that going to be too slow there? Well, let's see. There are 400 directions. No, that's not going to be too slow. So each line into grid Y. Probably don't need to support non-square grids, do we? I will anyway. This should start at 0, I think. Oh, we don't want to double count the outside ones, do we? Let's see. That's right. Y. Grid y0, grid x-1. No, sorry, grid y x-1. Why did I struggle with that? The grid yx is greater than highest, invisible plus plus. X equals grid yx, if highest equals 9. Right. Okay. Maybe that's it. Maybe that is all. Is incorrect. So what do we start out at? Okay, so the 16 is correct, the 23 is not. Must remember that the items in my grid are characters rather than numbers. Okay, well that's not the reason, but it should be a character height. One, two, three, four, five. Ow! We're double counting trees. Okay. What we will do is, once we've counted a tree, let's just have another. Out of memory. Ah, no. Okay, this will be fine. I just have to compile it, because the interpreter takes up a lot of memory on its own. Still wrong. That's annoying. And actually what I'm going to do is well, HW would be fine, wouldn't it? So we've got 1, 1, 2, 1, 2, 3, 1, 3. So 1, 1, 2, 1, 2, 3, 1, 2 should be there as well, because that's visible from the right hand side. Good. Now I need to compile it so that it will fit in memory on the real input. Part 2 sample answer is 8. What's the highest scenic score possible for a tree? The viewing distance. Stop if you reach an edge or at the first tree that is the same height or taller. Multiplies together the viewing distance in each of the 4 directions. Silent contemplation time. Got a bit of an idea. I think we're going to have, when we're going to have a second well, no, we'll just use the one SCAMP function, and this will have distance since 3, 4, 5, 6, 7, 8, 9, 10. And that will say how far it is since we last saw a tree of that height. Okay. Since we last saw a tree of that height or greater, I think. So the height here is grid yx minus 0. Scenic needs to be initialized to 1. So, if the distance since, this actually does want to start at the outside. If the distance since a tree of height h or greater is not equal to -1, and scenic yx is not equal to -1, scenic yx multiplied by distance since h. If distance h is -1, scenic yx is -1. Because if distance since the height is -1, it means we haven't encountered it yet. So that tree is visible from the outside. Now, having encountered this tree, we don't really want the distance since, do we? We want the position that it was at. Ugh. So the distance since h is p minus h. If the next tree blocks you, does it count as 1 or as 0? Its view is blocked immediately, it can see only one tree. Okay. I think that might be it, and now we just need to find the largest value . And hopefully it won't overflow a 16-bit int. Well, the largest it could be is 50 to the power of 4, which is 6 million, so I suspect it might overflow. Let's see. Oh, I'm still on part 1. Damn. Oh well. Oh dear. I don't want to lose it because I want to upload it to GitHub. Right, okay, where was I? One is incorrect. They all get initialized to 1. I don't need this. Argument here. Oh. If we see a tree of size 8, it blocks smaller trees, not larger trees. Okay. It thinks there is no tree. didn't change anything, did I? Didn't it say 65,535? Maybe I have an uninitialized variable. Maybe I ran part 1 instead of part 2. No, part 1 doesn't exist anymore, does it? What's going on there then? Oh, I'm reusing H. Damn. Oh, that's a blunder. Oh, I don't know. Capital H. So overwriting everything with -1. Okay, so what did height 5 in the middle of the 4th row? So that's 2, 3. Two, 3, visible from outside when scanning in 0, -1. Oh, have I misunderstood the problem? I thought we only wanted trees that were blocked from the outside. So this wants to be the problem's actually quite a bit easier than I thought. Is it that? Just realised I should have been checking the answer against -1 in the previous version anyway. Okay. But I think because I read in part 1 something about making sure there was enough tree cover, I for some reason thought they didn't want the treehouse to be visible from the outside of the forest. That's annoying. Maybe the problems are getting complicated enough that I need to be reverting to the strategy of reading the problem statement in full out loud. And now's the part where we find out that the number is too big to fit in 16 bits. I expect. Yeah, because if you can see as far as 10 trees in each direction. Oh no, that's fine. That's only 10,000. But if you can see much more than 10 in each direction, then it's going to overflow. So this is a lot slower than part 1 because of all the multiplications and because we don't get to break the scan when it reaches 9. Okay. Fingers crossed that hasn't overflowed. Not the right answer, okay. So I'm going to say it probably did. So what we could do is well, I don't have enough memory to put a big int in every cell, do I? Maybe just enough if I make the big ints 32 bits wide. But the multiplications are going to be much too slow. Maybe we'll do that pending a better idea. So, oh, I need to make the big int smaller. There's 64 bits by default. And just to give ourselves a better chance, we'll stop wasting all of these. I don't even think I need a +1, but I can't be bothered convincing myself. Should still say 8. Okay. Fortunately, I think if this is going to run out of memory, it will run out of memory quite quickly, because it doesn't do any allocation after it started scanning. Other than the other than initializing the answer, that'd be annoying, wouldn't it? Where it goes answer equals big new 0. If that was the point where it runs out of memory. Yeah, okay. So we don't have enough memory. Because the grid itself takes up 10,000. Our points take up 10,000, and then we've got 20,000 worth of big ints. That's 40,000. Plus the code, plus the code. What can we do about this then? Okay, I've got an idea. What we'll do is we'll have 2 of these. And this will take the pointer to the scenic. And then only at the end will we multiply them together. Do you reckon that's going to work? It's actually faster than doing the whole thing with big int multiplication as well. That's a good trick. I wonder if I'll be able to use that again. Let's try that then. Great. It's possible that this might still run out of memory. But it'll be about 10,000 better than the last version. Oh, it's not run out of memory. Okay, good. We're doing about 2 a second, so we've got 100 seconds to wait. Something like that. If this still says the 58,000 number, I'll be very annoyed, because it means it was nothing to do with big ints after all. Now we have 10,000 big int multiplications to do. Might be worth looking up how fast it can actually do big int multiplications. Based on the frequency that the lights are flashing, I think it may only be doing about 10 a second, which means I'll be here for about 15 minutes. Which means, if that's right, I might be better off killing this, finding a way to compare the magnitude of the multiplication without actually doing the multiplication. And then I can just print out the two answers, multiply them with the calculator. How do you tell if A times B is greater than C times D without doing the multiplication? Well, you can tell if it's definitely not greater if the two arguments are smaller. Like if A and B are both small, if A is smaller than C and B is smaller than D, then it can't be the case that A times B is greater than C times D. However, historically, when I've tried to add in clever tricks, I think it's ended up costing me time. I'd have been better off just leaving the computer to run. So that is what I shall do. Ah, we've got an answer. Please be correct, please be correct, please be correct. Yes! Great success. Well, that was very time consuming. A bit of a blunder on part 2. If I'd have read the problem statement thoroughly, that would have saved a lot of time. And today, if I get time, I want to do some profiling of big int operations versus normal int operations so that I can have a better estimate of how long something like that's going to take. I want to have written down answers to questions like, how many multiplications can I do per second with a big int 2? A big int like where... Oh no! I deleted it. Oh well, at one point I had big int 2, which makes the big ints 32 bits wide instead of 64 bits wide, which makes the multiplications presumably about twice as fast. No, if I'd have left that in, it wouldn't have taken so long. Anyway, we can have a look at the leaderboard, however, I think it might be bad news. Yes, oh dear. HBot has gained 9 points on me today. Anyway, very good. Thanks for watching, goodbye.